The next thing I want to show you how to do is something called linear regression. Let's say we had a bunch of inputs and their outputs that we could treat like x's and y's. And we want to come up with some sort of rule that would allow us to put in some additional inputs, some additional x values, and find the y values that go with them. The only problem is the rule that would describe these isn't perfectly linear. In other words, when we graph these x and y values, it might look something like this, where the dots are approximately falling in a straight line, but definitely not falling in a perfectly straight line. Well, we can do this with the help of the calculator. The TI-83 and the TI-84 have linear regression built into them, so it can actually do this work for us. Now, there's something we need to do first, though. There's a diagnostic command that needs to be turned on, so the calculator can tell us, once we do a linear regression, how well we fit the data. Now, the way we're going to do this, and you only have to do it once, and it'll stay on, is you're going to hit second, then you're going to hit the 0, and you go into your catalog. And again, the command that we want to use is the diagnostic on command. And you see we're here in the A's, so we're going to have to arrow down quite a bit. We're staying in the A's, then we go to B's, then we go to C's, then we go to chi, still in C's, arrowing down, as you can see, a lot of down arrows till you get to the D's. And it's DI, and I think I found it. There it is. On DIA, diagnostics off comes first, but we don't want them off, we want them on. So with the arrow pointing at diagnostic on, hit enter once, twice, and it'll tell you that it's done it. So now that our diagnostics are turned on, let's go look at how linear regression works. Alright, what linear regression will do for us is give us the line that comes the closest to many of those dots as possible. Now, what type of line are we going to get? Well, there can be different kinds. We can have several different types of correlation. We can have this would be a positive linear correlation. On the other hand, if the dots were arranged slightly differently, we might have a negative linear correlation. We might have good fits, or we might have data that gives us a very poor fit because the dots really weren't arranged in a very linear fashion. The calculator can tell us, again, how good the fit was. Now that we've turned our diagnostics on, we're going to get an R value. An R that equals 1 means a perfect fit and a positive fit. An R equaling -1 would mean a perfect fit with a negative correlation. And an R either equal to 0 or close to 0 would mean poor or no fit. Now we've got some data in front of us here that we can use. This came out of a book where we were putting in the size of a diamond ring in carat weight, and we were getting out what the price would be. Alright, now we're going to hit the stat button first, hit 1 for edit, and you have an L1 and L2 visible. We're going to want to put those carat weights, in other words the X values, into L1. So I'll type in the 0.05 and then I hit enter, and the 0.10, hit enter, the 0.15, and then the 0.20, 0.25, and on down the line, of course, hitting enter in between each value. Alright, now once all your X's are in, we go over, and we're going to start putting in y's. Remember to keep them in order. In other words, the y that was across from the x, those have to be across from each other in your table on your calculator. So the first y value I put in is the 39. Hit enter. And then the 79. And hit enter. Of course, if you mess one up, you can go back up to it and retype it. Alright, so 99 will be next. And the 159 is next. And the 229. And as you see, I made a mistake there. So I can just back up a little bit. Delete one of the 2's, and it's fixed. Alright, so moving on to 99. And the last number is the 495. Alright, so I have all my x and y values in place. You can go up and down, arrowing through to check them. Alright, so we're now ready to hit the Stat button. And we go over to the Calculate menu. And linear regression, as you can see, is option number 4. And when you hit enter, it gives you your equation. Alright, so your equation, first of all, the a value is the slope, and it's 1051.3. So our equation is y equal 1051.3x plus, we see that our y-intercept is a negative 32.9. So we'll say 1051.3 minus 32.9. Now, that is the equation, such that you can approximately plug in x values and get the y values to go with it. As we can see, we had a positive number here, so that implies that it is a positive fit. Also, looking at the calculator, we have an R value of 0.99, which means not just positive fit, but a very good fit. Now, if we set our window up correctly, knowing our x's and y values, we should be able to set our window up in such a way to be able to see these points and see how close our equation came to them. Alright, now our lowest x value was a 0.05. So we're going to want to go with maybe a -1, trying to get a little bit to the left of the low x value. Our highest x value was a 0.50, so I might go from -1 to 1 on the x's. Now the y's, of course, got a little bit bigger. So our smallest y value, since it was a $39, I might start at 20. Our highest y value, since it was $495, I might go to, say, 510. Now, don't forget, for our stats, we have to go in and turn the stat plot on. And now we can graph our points. And as you can see, those points were approximately linear. And a neat trick that the calculator can do for us, if we hit the VARS, the variables button, go down to number 5 for statistics, go over to the equation option, number 1 will put the regression equation into the y equal 2 screen for us. So now when we graph it, we can see just how good a job the line did at hitting all of those points. And if we wanted to, since our table, as you recall, our table of values originally didn't include an option for maybe a ring size 0.40, we can go to the table setup, tell it to start at 0.40, and since the equation's already in the calculator, when I go to the table, it tells me that for a 0.40 carat ring, I'd pay $378.59, and that is the estimate the calculator would give you for that table. So one more time, the procedure is under Stat menu, go to Edit, put in your X's and Y's, then under Stat again, under Calculations, do the linear regression, which is number 4, and then after that it's just a matter of graphing the points versus the equation and using that equation to make your estimates.